at you from his quarantine home to go over exponential functions. So if you were with me yesterday, we went through the first couple pages. I said if you could to try to practice this. A lot of people were complaining yesterday that they did not have a calculator. So if you go to www.cimath.com, right under where you could get the link for the YouTube, there is a link where you could find and download a TI-83 graphing calculator. Do that later. You'll be seeing I'll be using that here now. Do not know if it will work on your phone. I know it's not going to work on a Mac, as I was trying to do it earlier, so I'm still on the lookout for one of those. So if you do know a good spot where you can download the operating system for a Mac for a TI-83, let me know in the comment section down below. Okay, so let's go through this one now. So I will take out the calculator now that I have it, and hopefully that'll help a little people that were getting lost when I was doing those questions yesterday. I couldn't see the calculator. Okay. Guess who I am? Well, guess who? I used to love that game. Do you? We can't play questions because the delay is just way too long. You could just tell me your name. Okay. All right. So, oh, I lost it. First question says 5 to the x for x equals 4. So if they're all you have to do is substitute it. So that would be 5 to the 4th power. Same thing for the next one. It says 3 times 4 to the t. So that would be 3 times 4 to the negative 3rd power. And then this one here says 8 times 0.7 to the 3rd power. So it's just making sure that you know how to use the calculator. All right, so now I am going to go ahead and do that now with the calculator so you can see what the answers would be. And again, make sure you get online and download this calculator. So right there, I'll hit 5 to the 5 to the 4th power, and the answer is 625. So in number 1, the answer would be 625. Number 2 says 3 times 4 to the negative 3rd power. So I would do 3 times 4. Remember, this is the exponent button, and then I'll do negative 3. And I would have 0.046875. And that would be my answer for number 2. And number 3 says 8 times 0.7 to the 3rd power, and you'll have 2.744. And that's just a quick little warm-up for you and making sure that you know how to put those in your calculator. Now, when you go over to these next practice problems, same exact scenario, but there's a shortcut to it. Okay, so in practice question number 1 there, it says evaluate each function over the domain -2, -1, 0, 1, and 2. As the values of the domain increase, do the values of the range increase or decrease? Okay, so remember yesterday when we were going over it, we said if that first value of a is greater than 1, we know that it's going to be an increase, and we know that if it is between 0 and 1, I don't want to say a decimal, but because 1.5 is greater than 1, a number between 0 and 1, we know it's going to be a decay. So I'll see a 3, I know it's going to be a growth. 4.2, greater than 1, it's going to be a growth. 0.3, less than 1, so I know that's going to be a decay. And this is saying 4 times 3 to the x power, that's also going to be a growth. But now, do you want to sit there and do 3 to the -2, 3 to the -1, 3 to the 0 and get it? Well, what you could always do, remember this is the same way of saying y, you could go over here and create a table, -2, -1, 0, 1, and 2, and plug it into our calculator. So if I go over here, go to the y equals, and put 3 to the x power, and graph. Now we were doing that yesterday, so here's going to be our graph there. If you go to the table, second graph, and then I go up to my negative values, and there are my answers. -2, 0.1111, -1, 0.333, 1, 3, and 9. Okay, so then I could come over here, 0.11111, 0.33333, 1, 3, and 9. Okay, and that's what I would do for each one of these. They're asking me to evaluate or to find the range when the domain is -2, -1, 0, 1, 2. So for this one here, same thing, -2, -1, 0, 1, 2. Go over to my calculator. I'll go to my y equals, and I'll put now 4.2 to the x power graph. Very similar to the last one. And there you go. A -2.05669, -1.2381, 0 is 1, 1 is 4.2, 2 is 17.64. Okay. What happens if we don't do this? Let's go to the end of the video and I'll explain what may or may not happen. Okay. So then you can go ahead and copy that in that table there. Okay. I'm going to save myself some time. You have the table there. I'll go and put the next one. The next one said 0.3. Well, tell me why you're lost. I'm just say I'm lost. Where are you getting lost? We're just putting things in our calculator. Graph. I'll show you all right now. There's our decay. I can go to the table. So if you look here, this is the question. Okay, evaluate each function over the domain. So what they're telling you is I want you to use the domain -2, -1, 0, 1, 2. Okay. -2, -1, 0, 1, 2. Okay. Then what you're going to do is you're going to evaluate. That means that they want you to find the range. They want you to find y. Okay. So then what we're going to do is then we're going to go over to the calculator and we're just going to copy down our numbers. -2 was 11.1. -1 is 3.3. 0 is 1. 1 is 0.3. And 2 is 0.09. Okay. So those are the numbers that would go there. So here we just said was 11.1. Here was 3.3. That was 1. Then it was 4.2. That was 0.3 and 0.09. That's all we're doing. And I'll show you the last one just so you can see the table. Go to your y equals. And then you can go to 4 times 3 to the x power. Go to the table. Copy down. From -2 to +2. 0.4. -1 is 1.3. 0 is 4. 1 is 12. And 2 is 36. Okay, so you can take a second, you can go back later, hit pause, get the rest of that table there. Okay. All right, so now we're going to turn the page. We're going to look at some word problems here. So here, number 1 says an investment of $8,000 in a certain CD doubles in value every 7 years. The function that models the growth of this investment is 8,000 times 2 to the x, where x is the number of doubling periods. If the investor does not withdraw any money from the CD, how much will be available for withdrawal after 28 years? So all they're asking us to do here is to take the formula which they gave you, which was 8,000 times 2 to the x, and plug in the value for x. Now they said x is the number of doubling periods. Okay, so they said x is the number of doubling periods. And then they want to know how much money will be after 28 years. Yes, all you have to do is go to the channel, and all videos that we do are on the YouTube channel. So here is 28. So you would think, okay, I'm going to put 28 here. Okay, 28 it represents years, but they said x is equal to doubling periods. What did they say? How does this grow? It grows every 7 years. So you will get money at not every year, but every 7 years. So then the question is, well, what number goes in here? Well, how many times will your money grow in 28 years if it grows every 7? Well, 7 years, it grows. 7 years, it grows. 7 years, 7 years. That is how many times it will grow in 28 years. So 8,000 times 2 to the 4th power. Okay, so then I'll go over to my calculator. I'll go here and I'll do 8,000 times 2 to the 4th. And there's your answer. $128,000. So again, this 4 comes here, and now 28 represents years. The question said x is not years, but the number of doubling periods. And it says that the money doubles every 7 years. So 7, 14, 21, 28, your number or your money doubled 4 times. And that's why the x is 4 and not 28 and not 7. Okay. It is, yep. Here we go. A population of amoebas in a petri dish triples in size every 20 minutes. At the start of an experiment, the population is 800. So again, they gave me the formula. It's 800 times 3 to the x power, where x is the number of 20-minute periods. So again, okay, that's important. Number of, and now how does it? 20-minute periods. Models of population growth. How many amoebas in the petri dish after 3 hours? So I want to know, well, it started with 800 and it's going to grow. And in 3 hours when I come back, how much is going to be in there? Well, when does it grow? It grows every 20 minutes. So it's 20 minutes, 20 minutes, 20 minutes. And you want to continue until you get to 3 hours. Okay, so this is 1 hour, then 2 hours, and then 3 hours. So that's going to be 3, 6, 9 times. Okay, 20, 20, 20 for hour 2, 20, 20, 20 for hour 3. 1, 2, 3. So then right here, I'm going to do 800 times 3 to the 9th because of how many 20-minute times happened in 3 hours. Okay, so I'll go to my calculator. And I'll do 800 times 3 to the 9th power. And it's a big number, and it's going to be a big number because it grows a lot. 157,464,00. And there's your answer. Okay. And the last one. So here we go. Okay, same question, just a little bit different because there's no numbers per se. So a new car costs $15,000 to build in 2010. The company's financial analysis expects the cost to rise by 6% per year for the 10 years they are planning to build the car. The cost to build the car can be modeled by this function. T is the number of years, so number of years. Okay. The cost to build the car can be modeled by the function f of t equals 15,000 1.06 to the t. Okay, where it is after number after 2010. How much will it cost the company to build the car in 2017? So 2010 doesn't go there, 2017 doesn't go there, and 10 doesn't go there. Okay, they want to know Okay, t is the number of years after 2010. Okay, and they're going to go all the way to 2017. How much time is that? That's 7 years. So then you're going to go here, and then the time is 7. So then you're going to go 1, 5, 0, 0, 0, parentheses. You got to copy it the same, to the 7th power. And there you go. 22554.45388. Now, they don't tell you how to round, but it's your job to know how to round in this particular question. They're talking about money, okay? So they're talking about money. So this is 22,554, and then this is your cents. 10 cents, 15 cents, 25 cents, 30 cents. It's all 2 decimals. So you're looking at 45. Yeah, the delay gets me really mad too, Alfredo. And then, so then the 388, okay, we don't have to worry. The 3 says, well, stay the same, so it's 22554. And what was it, 45 cents? Yep, and 45 cents. And there you go. And that's how you kind of do your general word problems, okay? All right, so now, tomorrow, we're going to go over some of the more important aspects of exponential functions and some questions that I guarantee are going to be on that algebra regions. Now, a lot of people are asking, well, what happens if I don't do this? Well, I have no idea. What happens if we don't go back to school this year? Does that mean you're all 9th graders again next year? I don't know. Maybe. Do you get an automatic pass? Well, I don't know. Maybe. Does it mean you don't have to take the algebra regions? I don't know. Maybe. But maybe you will. What happens if we do go back to school and there is a month left and then you do have to take the regents and then you just lost all of this time? There are no real answers to any of the questions about all of these what ifs, so you can play them all day. The only thing you have to do is, you're all at home, and I can pretty much guarantee that you're probably very bored, so you might as well try to do something productive with your time, okay? So tell your friends, let them know that I am here doing the algebra, getting us ready for the potential of taking a Regents in June. We will wait. We will see. Hope everyone enjoyed the video. Leave a comment, hit the like button, hit the subscribe.